Hello, everybody. Welcome to the stream. Can everybody hear me? And can everybody hear Aaron? Let's do a quick mic check before we talk into the void for too long.
Testing. Testing, 1, 2, 3.
Can we
Check,
get a
check.
thumbs up if you hear us? Cool. So I'll wait for the thumbs up, and in the meantime, I will... Mic check is a +1. Thanks, Philip. Cool. I'm very excited to have Aaron with us today on the stream. Some of you watching may have been following Aaron's streams. He's been doing a lot of cool stuff lately. And I think it's fair to say, Aaron, that you are the Elm AST transformer in chief. Between Elm format and your latest project you've been working on, your Elm refactoring tool. So I'm really looking forward to diving into some AST transformations in IntelliJ with you today. But yeah, you want to say hello?
Hello. Yeah, maybe that is accurate. I feel like I haven't earned that description yet because I haven't really been sharing about a bunch of the cool stuff I've been doing. And actually, for some of the refactoring stuff I've been working on related to Elm format, I've been learning all this really cool stuff about higher order types in Haskell, index types, recursion schemes. So I'm also really excited to hopefully put together some blog posts about some fancier back-end functional stuff in the future as well.
Oh, cool.
But yeah, I was excited to hear that you've been working on some refactoring stuff for the intellij-elm plugin, which I've been using the intellij-elm plugin for all my Elm work for, I don't know, like 6 months now. It is just like so much better already than anything else.
I know it is, and it's in a really cool place for contributions, as hopefully we'll be able to demonstrate. I hope that this stream will serve as a little bit of an introduction, or if nothing else, maybe to make people feel a little less intimidated at the prospect of contributing to IntelliJ-elm. I'm really hoping that that other people might get excited about some of the low-hanging fruit, because there are refactorings that are very involved, and there are some refactorings in Elm, especially with Elm, because Elm is has so many guarantees that you can make so easily. It's not a dynamic language; it's a static language. Things don't have side effects. It's just data. In fact, you never directly do side effects in Elm. You just are giving expressions that represent data. And then Elm does the dirty work for you. So you can just, as long as you can change the, as long as you return the same value, you haven't messed anything up. You're not mutating anything. You're not doing side effects. So there's so much low-hanging fruit. And I hope that people will get inspired to do some contributions to some of that low-hanging fruit so we can make IntelliJ-elm better. Because as Elm developers, I firmly believe that we deserve best-in-class tooling because Elm is made for it.
Yeah, and what I'm excited to show people too is what the experience can be like to have more of these tools available. I think people coming from the JavaScript world and even from the Ruby worlds haven't had that experience. You've done Java professionally in the past, right?
I have.
Yeah, so I've done a ton of Android development.
Even though Elm is so much nicer, the IDE tooling made it a pretty positive experience.
Yeah, and I kind of learned really how to use IntelliJ when I worked at Pivotal Labs, starting with Android apps in Java, but then later some Java backend as well. And man, just it changes how you think about code when you have really good tools. You start to think about the structure of your code, and you're kind of just manipulating it more concretely, almost feels more like assembling blocks and moving them around rather than always translating things into words, into syntax, and back and forth and back and forth. So it really it's just an amazing development experience, and I'm hoping we can get Elm to move more in that direction.
Me too. Yeah, I think what I see a lot of is that I think it's, as you say, when you have that experience if you're working with Java and languages like that, where it's almost a necessity to use the IDE, because it's so cumbersome to generate all the getters and setters and implement the abstract interfaces and create the anonymous classes and all these things. It's like very hard to do as a mere human. And with Elm, we can rely on how easy it is to express really powerful things with custom types and a nice syntax and a nice compiler. But it can be so much better with tooling. And I think it's not in most people's Elm toolkit to actually do what I would call a true refactoring, where a provable refactoring, as opposed to a design rewrite, which is what most people mean when they talk about refactoring. It's just like, delete this code, write something with a new code structure that I think pretty much does the same thing in its place. And that's very nice. It's a very nice experience in Elm, but refactoring tools can make it so much nicer.
Yep, exactly.
So cool. Let's dive into it. So should we show people our beginning of some brainstorms for refactoring ideas?
Yeah, and I don't know if there's any quick overview of IntelliJ in general, or some of the stuff you've been working on, or should we jump to the ideas of refactoring first?
That's not a bad idea. Yeah. So we'll get into, I guess, the details of the specifics of using the IntelliJ SDK as we get into the actual code there. It is the SDK has some nice docs. In fact, one of the contributions I've been hoping to make to IntelliJ-Elm is just to give some resources for getting started with it in a contributing markdown file. So these SDK,
well, maybe the notes I'll be taking today will be a good start for that.
That sounds like a good plan. Yeah, and Philip is asking, will we be writing Java or Kotlin today? We will be writing Kotlin, and I've been pleasantly surprised with how nice it is to write Kotlin code.
I kind of left the Android development world right as Kotlin was starting to get popular, so I'm actually excited to see more of it.
I think there are a lot of features that Elm developers will appreciate about it. It's amazing how certain details like smart casts make things feel a lot more like Elm, as opposed to having to say if the type of this thing is this class, then cast it to this class. But a cast is inherently unsafe. You check for it just like you check for null, as opposed to if the type is this thing, and then in that if block, the language knows that the object is of that type.
Cool. So what did you have to do to get started? There's like a special SDK plugin you have to install into your IntelliJ to start working on this kind of stuff?
What you do to get started, that's a good question. So it may vary from platform to platform, but for me it was pretty straightforward. In fact, we could even run through it. Let's see. So what you do basically is you clone Keith Lazuka IntelliJ-Elm. Well, let's see. I've already got it here, but we could do IntelliJ-Elm 3 because I've done this multiple times.
Hey, I'm on Elm Format 3 on this laptop as well. And also, I was up to No Red Ink 3 when I was working in No Red Ink still.
Sometimes it's handy to be able to switch between different versions, yeah. And then there's this Gradely thing, Gradelu, this Gradle wrapper. So you can run that. You should be able to just run Gradle W build.
Okay, it's going to download all our Maven dependencies.
Probably take a few minutes. Yeah. Mm-hmm. It's doing
Cool.
magic Java
I
things.
mean, I'll trust that that works.
Yes. Yeah, it's like it's like those baking shows where they like put it into the oven and then they already have one that's just been baked.
Oh, right. Except we have to have unique folder names so they
That's
can tell
fair.
in the cut.
Exactly. Yep. um, but I mean, basically, you're going to want to install IntelliJ. I've actually got this tool here, which is kind of nice. Actually, let me open up the Elm SPA example app.
Okay.
And
Do you want to bump up the font?
oh,
Maybe
Philip is, yes, I do. Thank you
three
for the
ticks.
reminder. Philip is saying, I love Git's work dir features for that kind of thing. I'm going to need to research that. Have
Yeah.
you used that?
Yeah, I used it only really for the no-red ink repo. It basically shares the .git folder across multiple checkouts.
Oh,
Um,
okay.
but I've actually discovered some bugs in certain Git-related tools that like don't
Uh-huh.
understand workdir properly.
They
But
like
yeah,
make
it's
assumptions about it, yeah.
yeah,
Hmm.
yeah, it's mostly worked great.
Interesting.
But you don't really need it for tiny repos, only for big repos where you've got hundreds of megabytes of repository.
Mm-hmm. Interesting. That makes sense. Okay, so I think let me just kind of um walk you through a few of the core concepts because this is actually Aaron's first time looking at intellij-elm stuff. For the past like 3 weeks or so, I've been having some fun with working on some features for it. So I'll share with you what I've learned. So first of all, I've got this package installed. You can install a plugin called Psi Viewer. And this Psi Viewer plugin gives you the ability to see a PSI, which stands for Program Structure Interface. So in IntelliJ,
Oh,
in
so
the
what? This
IntelliJ,
is like the DOM inspector for IntelliJ plugins,
that's a
sort of?
fair way to describe it. Totally, yeah, exactly. This is what the syntax plugin for the language you're looking at has parsed into in IntelliJ. So project structure interface is IntelliJ's.
Oh.
It's like I don't know if the proper term is like a concrete syntax tree, but it's like it
Hmm.
represents the actual syntactical concept. Is this a function call expression, a parentheses expression, a binary operation,
Hmm.
and then it represents like the actual concrete white space and characters within that. So
Oh,
like
cool.
let's look at decode.succeed. If I pull up the PSI viewer, we can see it's an Elm value, and it's actually an Elm function call expression. The parent is an Elm function call expression.
Yep.
The or like what would another example be like? Is there an
Hmm.
like here's
So,
like a list.
so this is pretty similar to like the tree sitter AST as well, where it's like pretty dynamic. It's not like very strict union types, but it's kind of like you have a list of elements as children everywhere.
Yeah, it does. I haven't used tree sitter, so I don't I don't know exactly what that feels like, but it is the relationships are mapped in, a sort of object oriented hierarchy. So you
Hmm.
do have that going for you where well we might get into
Or
it, but there are
it's a
certain
lot like the DOM as well, where you can just have all kinds of stuff crammed in there.
yeah, and there are certain places where I mean you can abstract things where certain assumptions where like if something is a
Hmm.
function call, like so for example, if we look at a function call, if I go to the Elm function call expression class, this is in the IntelliJ Elm project. Um, so there's sort of like I think the underlying like AST
Oh.
parsing, it's actually like there's this Java code generation thing that uses like where you define like a lexer, and there's actually like a code
Hmm.
gen step, which
And then so we could actually define new properties on that function call node if we wanted to,
We
for whatever reason or something.
Yeah, and
Hmm.
usually what I've observed happening in this project is that they're making certain assumptions about like where the parsing, I think there's like some lexer that generates code, and instead of like writing directly things that are working with that lexer, they'll know that if something goes into this type of class, by the way it gets parsed, they know that it's going to have arguments, which are going to be these elm atom tags. And so they do that by, as you can see, like direct children dot filter is instance elm atom tag, and then drop the first one. So it's sort of like just abstracting away these guarantees that they know these types will have.
Hopefully there's test coverage for all this stuff, right?
There is amazing test coverage.
Excellent.
It's fantastic.
Cool.
It's like end-to-end test coverage, which is it's a mixed bag, but I think it's quite nice because it gives you a lot of confidence that like not only are the internals working, but the like when a user goes to try to use a refactoring, it's going to work, which is great.
Oh, cool.
Yeah, it's quite nice. So
So I know I kind of like to learn things by just getting my hands in dirty, probably diving in sooner than I'm ready to.
Exactly.
Although I was commenting on my stream the other day, for video games, I tend to like read the instruction book back to back before I start playing. But I guess with code, I kind of have the opposite approach.
That's fascinating. No, I'm a fan. I'm a fan, and I think so. Here's what I think could be kind of fun is Aaron. I know you and I are both advocates of TDD, and it's also very satisfying to like get something working right away, even if you sort of have to lie, cheat, and steal to get there. So it's TDD time. So let's fake it till we make it with a hard-coded passing test and see if we can actually run it as a refactoring. That's what I'm thinking. So Aaron,
okay.
Before the call, Aaron was suggesting that this might be a fun refactoring for us to work on, and I think this is a good candidate. So
and
you want to just introduce this refactoring?
Yeah, I think it's interesting to talk about because this was something that came to mind when I was starting to think back to my Java days and kind of like test-driven development demos that I used to do. And kind of this concept of, or related to the test-driven development concept of writing the simplest, dumbest implementation that makes your test pass, and no more code than that, and then slowly evolving it to where you actually want to go. And a really interesting place that manifests is around lists of things and processing lists, where often you can write a test, although in Elm this is harder to do, but like in Ruby and JavaScript, it's really easy to write a test for having a list of one item. You make that pass only for the first item, and then you later add tests that like, oh, it does it for all the items. So this refactoring is kind of related to the idea of starting with simple code and gradually evolving the implementation to be complicated enough that it can handle all the edge cases you need.
Yes.
So the example here, I was thinking, all right, in processing lists, often you start with a list.map to just handle each item individually. But then later on, maybe you realize what you really want is more complicated. It needs to kind of thread state through the processing or keep track of something as it goes through the list or insert separators or whatever. So like the first incremental step, you're talking about like doing these tiny mechanical and provable refactorings.
Exactly.
The first incremental step in that kind of evolution of an algorithm is to change from mapping into folding, which like gives you the next level of power in processing lists.
Yes, right, exactly. And you can express it, the simpler form, you can express directly map that to the more, map it, no pun intended, to the more complex form.
Yep. Yeah, so the after here code that I wrote is a list fold that basically does the exact same thing as the map. And I guess you could prove that somehow. I'm not like a mathematician, but those should give the same result. And then if you transform the map into the fold, then maybe your next step would be maybe to extract that lambda into a let block or something, and then start putting more logic into that anonymous function to do fancier things than you would be able to do with just the map.
Right. It's actually this cool sort of pattern where you you do a provable atomic refactoring that unlocks this part of it that you couldn't touch.
Yep.
And that's a really cool another one of those is like if you have like sometimes you'll pass in like the identity function. You just say like this takes a thing and returns a thing, and then you want it to be expressed this way because now you can do something with it. Now you can do this to it, whereas it's sort of locked in when it's written this way. Or there are a lot of cases like that,
And I think like this is the type of thinking that I learned from doing code in an environment where interactive refactorings were available. And I think also this is kind of like hard to explain what that experience is like in words, but like I would really love to have these things exist for Elm so that I could start putting together some really cool demos of how to use these kind of tools to like change your thinking and make code a lot safer to work with and a lot faster to work with in a lot of cases.
Exactly, because you should be able to, what I would do if I wanted to do a change like this, if I had this refactoring tool, I would literally just hit that refactoring, commit, and like ideally just ship it because it hasn't changed anything. Like I think of it like when you're playing a video game and you make a save point. You've got this checkpoint. Like if anything goes wrong, you're gonna get back to the safe point earlier.
Yep.
You have less work that you've lost along the way. It's the same with commits. I like to make provably correct changes, and then I know that stuff is not going to break anything. I can just ship it and forget about it. But then this one thing, I'm not sure if I'm going to break something that I didn't intend to, and now I can focus on that part of it.
Yep. And just a note for the hardcore gamers out there is a test-driven development practice where you set it up so that you make a change and then it'll automatically run the test.
Oh, yes.
And if your test doesn't pass after that change, it'll just revert all the code you've written since your last checkpoint. So if you're hardcore, you can go into that stuff.
It's fun. I'm definitely going to do a stream at some point on that. You're welcome to if you want to join me. We could do a TCR session. That'd be fun.
I'm a little scared of that. I still have to beat Celeste before I can do that.
It's so fun.
All right, well, let's jump into this.
Let's do it. Okay, so first things first. Let's write a test. We're gonna need like a little bit of boilerplate in order to do that. Oh, and let's see, what branch am I on? I am on the branch that has a bunch of stuff that I'm working on right now. So
jars.
Let's go to master. Yeah, I might have something a little funky with the my SDK setup right now. I think I used like a later version of the SDK and gets confused.
Well, great. Debugging obscure errors, that's what live streams are for.
Totally. So let's dive into the tests here. So the tests are really cool. A lot of this stuff is modeled on the Rust structure. So if you look at the IntelliJ Rust project. So if you're curious about how all of this works, Keith Lazuka pointed me to this. He said that this is the source of inspiration for the architecture of this project in terms of the tests, the organization of the code. So IntelliJ Rust, the people who maintain this now work at JetBrains, and they're like officially building stuff for them. Okay. And they've done a really nice job with this package, and it's written in Kotlin. It uses the same test structure. So this is a great source of inspiration to just look through this code. I'll post a link to it here. Hey, Ryan's here. How's it going? Compiling Elm to the JVM. Yeah, that's right. So here's
I guess
IntelliJ Rust. Here's their
I'd
architecture
imagine
background.
the IntelliJ SDK probably has a decent like introduction guide
It
as well
does. I'll
somewhere.
I'll link to that too.
Cool.
So cool.
Lovely.
So let's dive in. So okay, so let's look at some tests, and what we're gonna do is called in IntelliJ terminology. It's called an intention, which is just hovering over something. Like for example, if I hover over this, you'll see there's like a little light bulb, and it
Yep.
says add to exposing list. If I
And
click
that's like
that,
Alt Enter is the shortcut there too, I
exactly,
think.
Alt Enter is the shortcut.
Hmm.
So now you can see there's a little E because this is now exposed. Or if I, and if we go up to the top of the file, you can see the diff included that. If we go back
Oh,
down,
I
we can
see.
unexpose it.
So you chose the expose publicly intention.
Exactly. Yep.
Got it.
Yep. So that's how that works. So that's an intention. An inspection would be like if I do this, then it's like I don't know what this is. And that's called an inspection because it's actively looking for those. But an intention is when you just sort of like look at what's currently under the cursor, and you look at the AST, and then you say which intentions, which actions are available based on that. So that's what we're going to do.
Got it. So it's yeah, this is coming back to me from working in Java stuff. So that's like operations on valid code as opposed to things like warnings and compiler errors and stuff like that.
Yeah, and it could, I mean, like what are some examples of inspections here? Like, like an unused value, right? So that's valid.
Oh, sure.
It's like the same type of thing, but it's actively going to scour the entire code base and look for those. So it's performing computations
Oh, I see.
proactively in order to look for those, whereas an intention, your cursor is in a certain place, and then it looks for possible transformations you could make to it.
Yep.
Which is sort of the user experience we want, because you look at some code that looks like this, you put your cursor on map, you say option enter, and then it says, would you like to change this to a fold? By the way, Is there a reason you chose fold R, not L? Because I always thought that fold L was more performant, and to be honest, I never understood the reason for having fold R. Is there a reason for that?
Well, the reason I chose it for this refactoring is because if you put fold L there, the output will be in the wrong order.
Gotcha.
So you'll have to reverse it.
Gotcha.
So if we finish this, we can add a second option where it'll give you fold L and add the reverse for you as well. Gotcha. But then it also will result in different code depending on if the items parameter is curried or not. And so this is step one of the deep iceberg tree of refactoring options.
But yeah, there's so much value to starting with that low-hanging fruit and then take it from there.
Actually, and I was thinking, another refactoring then could be, convert a fold R to a fold L, or vice versa. So then it's just like smaller steps, and the developer can choose how many they want to apply, what order to do them in, so forth.
Exactly. Yeah, totally. And then we get the satisfaction of being able to ship a cool feature in the meantime. Okay, so I'm going to copy a test here.
Okay, so our goal is to make a passing test that checks that nothing happens when a newly created intention with some name we're going to add is invoked. Is that our goal right now?
That nothing.
I guess why don't we bring this up and let me see what this test actually looks like.
Sure. Let's see. So this is going to be like a map to fold intention test.
Okay, cool.
And
does each one of the intention classes contain exactly one intention, or can a single class provide multiple intentions?
Right. I'm working on a pipeline, like to or from pipeline intention, and
Mhm.
I initially thought, oh, I'll have like a single intention that lets lets you turn it to or from a pipeline. Um, it turns out you can't change the name of you can't dynamically change the name of the intention. It's like a single name. And so it makes more sense for the
I
user
see.
to see remove pipeline or transform to pipeline, and actually, like,
Got it.
you can fully pipe something or remove it if it's like partially piped, like if there's still a function call with some arguments.
Got it. So like if later we wanted to add the opposite refactoring to
Exactly.
like convert a fold into a map, we would need to be making a separate class.
Exactly.
They can't both be in the same class.
That
Okay, got it.
that's generally what turns out to be the most natural for the user and everything here. Yeah.
Cool.
Um,
Sounds great.
so let's see. What did we copy? We copied uh, add exposure intention. So here's what the intention looks like. So being a sort of JVM language and all. Oh, let me check the chat real
Whoa, whoa,
quick to
whoa.
be.
We're looking at code here. We've got to do our tests first.
Well, we do
What do
have
you...
to. Yeah, you're right. We do have to do our test. I was just gonna show this get text and all, but you're right. It is gonna yell at us for not having certain basic things wired in. But you're right that we
Oh,
should have
okay.
the test yell at us. Let me just check in at the chat real quick.
Cool.
So it's not inlining per se. Where would the alternatives come from? Ah, yes. I think we basically hit on that. That the we'd have to have an intention for each possible thing you could transform. So you could potentially have 5 different ways you could change in a particular like cursor position. Okay, so
Actually, yeah, we should actually hit back on that relationship of inlining to these kind of transformation refactorings, because the way I did it in the refactoring tool that I've been working on is kind of interesting related to that. So we should circle back and touch on that later
okay,
on.
cool. Yeah. Okay, so test. Now, what were you saying, Aaron? Were you saying that we should test when it's actually not available, or test when it is available and assert that it doesn't change anything?
So what is this? Okay, what does this test do? I am not familiar with tests in Kotlin yet, so let me understand the
So
syntax here.
this is quite cool. So this is saying, well, okay, so it's literally just a function, and I think that this syntax means that the name of the function can include weird characters like spaces. So this is literally a function called this string. And
Okay,
if the name of the function starts
got
with
it.
the word test, then it will run it as a test,
Okay,
as some languages like to do. And then do available test is just, again, it came from the architecture of the IntelliJ Rust plugin that you have these like Elm intention test based things, and it
okay, so
gives you
that's
the
from the
ability.
superclass.
Yeah, and you wrap it with an instance of our intention, which is going to be a new thing we're going to put in here.
Okay, so we need to rename that to
Yeah,
start with. That needs to be mapped to fold intention.
exactly.
Let's should we do that
Yeah, let's
right
do
now?
that. Fold
And then what? Can we alt enter to create the class?
map to fold. We absolutely can. I don't know if it'll create it in the place I want.
Well, then we can alt enter to move it to
Let's
where we
see.
want, right? We gotta get into the
Exactly.
refactoring lifestyle here.
Exactly.
Gotta roll with it.
I totally agree. We've got to dog food, even if it's in a different language. So we're going to create map to fold intention tests.
Oh, to be able to run this. Got
Wait
it.
a minute. I wanted
Oh,
to
that's
create a
the
class. Create class.
cool.
Extract to separate file. That's where I
Cool.
want it to be.
Lovely.
And intention action, I actually want it to be... Wait, doesn't it... isn't it going to complain because it needs to be an Elm intention?
Apparently not. It's just not imported here.
It's a little... Huh.
I guess the test harness actually works more generically than just with Elm stuff.
Yeah, that's kind of surprising, actually. That may just be an
Okay.
oversight, actually.
And then we can alt-enter on that to create the stubs
Wait,
for
what?
all the unimplemented
Oh,
methods,
it's not
right?
abstract. Yep, we can implement the members.
Yep, select all. Oh, you got to select them all there.
Oops. Oh, yes. Cool. There's no button for
Shift.
select.
There you go. Yeah.
Cool.
Yeah.
There we
Hey,
go.
programming is fun again. None of this like
Yay.
manual typing, moving the cursor
Exactly.
around, using the arrow keys, or like, what is it in Vim? You do like your J7 to move down to the bottom of the curly brace.
Exactly. Wait a minute. Now this is saying... Oh, yeah. This is saying it'll take any intention action. That's interesting because I would think it would say... Oh, maybe it's the same, actually. Maybe there is no
I guess
Elm
we'll
intention.
find out what missing features are in that superclass.
Yeah. Okay. So let's express our intention. So if we have a function, we can just roll with the function they've got here. And
Okay.
so here's the example you gave. We're saying
Cool.
list.map f items. It doesn't, for our purposes here, we don't care if it's defined or not because we're not going to look at that information.
Oh, and actually we want this to still work even if those things aren't defined, right? So
yes.
you aren't limited to only working on valid code.
Right. Right.
Okay, cool.
Now this caret is a helper that's part of the infrastructure that we get for free when we do an Elm intention test base. So
Cool.
if the cursor, let's just put it right in the map here, that's going to be where the cursor is in the test.
Okay, sounds great. So this is like, we have that code there, we come here, we're going to click with the mouse right there where the caret is, then we're going to hit Alt-Enter is basically the scenario.
Exactly, and then we're going to perform this intention. So we're asserting that not only is that intention available, but it's going to do the right thing. Let me check the chat real quick here. Maybe there's an Elm intention action that already implements some stuff. Yeah, I feel like there might
I guess
not
we'll
be.
see. But we don't have a failing test telling us to change the superclass.
Yeah.
So we may not.
I think
that
it might just not
Come
exist.
on, guys.
But let's.
Come on, folks. Excuse me.
Okay, so let's see what happens.
So we're expecting to see a test failure with the diff basically showing that nothing has changed.
Well, first we're going to get our exceptions.
Oh, right. All of our to-do exceptions.
Mm-hmm. Oh, wait a minute. Did I put this in the wrong place? Is this in test? This is in test.
Okay.
Which maybe won't cause any errors.
Shift F6 moves it?
That might rename it. Oh, not implement. So we got what we expected. Yeah, should we move it? Let's see.
Yeah, I'm okay with that.
Move.
Oh, just plain F6. Okay.
Oh, nice. Is this what I want? Let's see.
I'm used to there being, it lets you select whether it's a source or test folder, or maybe it's considering the packages in the different source folders different. I don't know. We can maybe just drag it at this point.
Destination directory. Here we go.
Oh, yeah. Yeah, that's it. Cool.
Nice.
Come back to me, Java knowledge.
There we go. Now we've got it in the right place. We can rerun the test, and it's going to say something very similar.
And I guess, like on our to-do list later, we're going to have to somehow hook it. Oh, no. This test should fit. Oh, what? Does it introspect and just automatically install all the intentions that exist in the jar? Or why don't we have to do any wiring to say that like this new intention needs to be included?
When we get to the point, I think when we resolve these to-dos, or we can just hard code some things. I think it's going to
Mhm.
complain that there are like some XML files that you need that will tell it like about the feature. So when you install the new version of the plugin,
Okay.
it'll describe
So
the
like
feature.
if we installed the plugin now, we wouldn't see this yet, but we'll deal with that later.
Actually, I think it's going to keep us honest about that, and it's also going to want us to add something to this XML file which defines the intentions, much like Android type development. So you know the dance. But yeah, let's. Why don't we get past what
Cool.
the test is telling us about? I believe the test failures will tell us about that, which is nice. Start and write action.
Cool.
Is
Sounds
this an
good.
optional one to override? I feel like this might, like if I delete this, nope, that's necessary. Start and write action. Sure. Get family name.
The screen share froze for me.
Uh-oh.
There were some internet issues.
Internet weather.
Okay, I think I'm up to date now.
Okay.
Oh, you were typing in true.
Yes. And by the way,
Okay, I think I'm
Kotlin,
all right now.
in Kotlin, everything is an expression, but you still have to say return, which I find for its context, that's a really nice compromise. So like if is still an expression, so you don't need that
Cool.
ternary conditional stuff.
Cool.
Oh yeah, we should make sure that we're doing the specific failures that it's telling us to. Get family name grants.
Okay.
Not yet implemented, which is coming from line 22. Get text is like describing it. So this would be like
Oh, okay. Convert.
yeah,
I mean,
like
what? Convert list.map to a fold. Or I mean, I guess maybe the description would be more like transform or like allow the tracking of state while processing list items.
That might be a little
Or like needs to be copy workshopped a bit.
Yeah, but we can always improve that. Let's get it happy for now and see how we feel
Cool.
about it. Loop back around to that.
And what is the family name? Oh, get text is actually what's in the pop-up menu.
Yes.
Okay.
Now it's complaining about is available. How about true? What do you think of that?
Sounds great. Wouldn't that be context dependent?
Oh yes, absolutely.
Oh, the context would come
But we
from
can write
editor
a failing
in there.
We can actually yes.
Yeah.
And we can
Okay,
actually
cool.
write a failing test that says whether that asserts that it's not available with the cursor at a given point.
Cool. Can we put a to-do comment in our test file for that?
Absolutely.
Oh, cool. We're there. Great.
It forces us to link this look at context. We're probably going to want to like oh, wait a minute. Isn't there like a get context? Well, we'll get there, but this is I thought you returned like a context. Oh. Because there's this find applicable context. Is this like an optional thing?
Well, that's the superclass you were talking about. Elmet caret intention action base, line 14.
Aha. Yep, that is what we want. That is exactly what we want.
Okay, but
what do you
we
reckon,
don't. I
Aaron?
mean,
should we get this passing
well,
doing nothing first?
Yeah.
Well, this
what's
is
our failing test now?
Yeah, what's our failing test? We're probably, in order to get this passing, we're probably gonna need to have the actual context, but we'll see what we can do. So, okay.
Okay, so
This is
invoke
a
is
to-do.
blowing up.
So invoke, well, that'll not blow up.
Just okay. There's no return value. I see.
Mm-hmm.
Okay,
It's
cool.
called a side effect. I'm not sure if maybe not sure when the last time you dealt with
Yeah.
one of those was, but it's
I
a
mean,
direct side effect.
I think my preference from doing Java was to have the
Uh-huh.
like implement method stubs to just return empty bodies rather than throwing exceptions. So we
Oh,
didn't have to
cool,
do all
cool.
this like clean up the to-dos step.
Mm-hmm. Like have this return an empty.
Well, rather than putting the to-dos in everywhere, it just puts empty like default return
Oh,
values in
gotcha.
for everything.
Like this. Oh, okay. That would be the actual thing you'd have the IDE do for you.
Basically, yeah, doing this
What
step
we're
that we're
doing.
doing right now
Gotcha,
for us.
gotcha. Yeah, that makes sense.
Cool.
Okay, so here's our failure. So this is awesome. So like this is very nice
Oh,
to work
great.
with. Isn't that
Yay,
cool?
comparison
Yep,
failures.
yep.
Yep, I remember these.
It's great. It's great. So it's saying, okay, I went in there, I found the intention, which actually, I guess maybe it's not taking into account this like registration in this XML thing. We'll actually run it and test that out in a minute. But
Cool.
it ran it, it found it, and it actually did nothing when it expected it to change it to this. So
Cool. Okay. Well, perfect.
that's a good start.
What, do you do a whip commit at this point, or do you wait till things are passing before you
I
commit?
usually wait till I get something passing.
Okay.
Unless it's like unless I'm in a really bad place, but like unless it's like really hairy and my hand is forced.
Cool.
Um,
Well, because I don't really know how to write these things yet, I think we
mm-hmm.
should now just switch the superclass to be the
Yeah,
superclass from the other, and we can kind of learn from the code that's there.
yeah, that sounds good. So, is there a magic thing to like use a different superclass, or do I just type it?
Um, there is. I don't know if there's a shortcut. Can you look in your refactoring menu?
Oh, good idea. Yeah. There's like Control
Although it's a
T, but it
generic.
doesn't work there. Refactor this. Don't see it there.
Okay, let's just type it.
Show context actions. Yeah. Okay. So context is something that we define. So we could define like
Okay. Should we just copy it from the others so I can see what we're not including?
Context. There you
Oh,
are.
it's just a data structure, like an
Yep.
Elm record. Okay, and we'll just have an empty one for now.
Yes. I guess we have to say map to fold intention dot. Yes.
Okay.
Now it's angry because we're not implementing the right things.
Cool.
Okay. So now we have this find applicable context, which we return a maybe context. So like if we return null here, for example,
Then it won't be available.
exactly. So we'll get a test failure. Let's
Cool.
prove
Oh,
that.
and let's delete those extra fields on context on line 12 or whatever.
Yes. Can it not be empty?
Oh, okay. Well, we can add a like not used field or something. Yeah, there we go. Is there a unit type in Kotlin?
There is a unit. Oh, oh,
Okay. It's too harsh on us. I guess just leave it as it was.
yeah. Or I could say like integer. No. All right. Yeah. So failed. Oh, it failed to compile. Now it
Okay.
compiles. Oh, missing a vowel. Yeah, Philip is pointing out that I was missing a vowel. I think he's right.
Oh, I see. Oh, okay. So
So I
val
should be able
unit
to do
colon
like
unit.
that. Yeah. Yep, that totally works. Nice, Philip. Um,
So val means it's oh, it means it's a field. It's like a getter setter property.
there's val and
Something.
var. Um, so
Oh, so val means it's a constant or immutable.
yeah, I think it means it's like an immutable reference, so the reference can't
Yeah.
change.
Okay, cool.
It's funny like thinking about all these nuances. Like things are so simple with Elm where it's just like, yep, like references are immutable, the underlying data is immutable. Not much to think about. Like, what if I declare it
Yeah.
this way? Could that be causing an issue?
I mean, you don't even think in terms of references in Elm. You
Exactly.
just think about the values.
Yeah, exactly.
Okay. So wait, what was the failure?
Well, the
Click to see difference. Okay, still the same
it's still
thing.
the same thing.
Okay, so yeah, okay. So to make this pass, we're gonna need to do something in invoke, right?
Yes.
Can we look at the other one? What is the other one we were copying from?
That was add exposure intention, and actually, I think let's see. So one thing that we might want to do is like let's just from the work I've done with some intellij-elm hacking, I think we basically want to take the context that we have under the cursor from this class that does for us, right? It gives us this context, and we basically want to like grab the we want to pass that element along, but we want to make sure it's of a certain type. So like I happen to know this is going to be an Elm function call expression. So like
Okay.
like the simplest thing we could do is if we take that function call expression and then we just replace it.
Oh, I see.
So like here.
Yeah. Well, okay. So I think you're a little beyond my understanding so far. Could we try to do I'm assuming in invoke somewhere, it's going to be creating that new AST that we're going to stick in. And I guess you're saying that we don't have the place to stick it into yet,
Exactly.
is why we need the context.
Exactly.
Okay. Could we start with
Mm-hmm.
building the new AST part, and then when we get to the point of not having the place to stick it in,
Yeah.
maybe explain this, because it's like it's not really clicking to me
Yes.
what I need to be listening for right here, right now.
Sounds good. Okay, so let's
Okay.
just pretend that we're in invoke, and we've been
Okay.
invoked with the appropriate context. Okay, so
Okay.
let's just pretend that that's the case. So I'm gonna
Like,
say,
actually, does invoke get called in the test right now? Like, if we throw an exception in invoke, will that
it
get hit right
doesn't.
now?
It doesn't because we're returning null. We can prove that.
Okay, yeah, let's prove that. And then we can work towards getting that error to be the one we
That's
get.
a great idea. Yeah.
Okay.
This doesn't get called. Is not gonna get called.
Meaning the test should still fail in the same way that it was before.
Yep.
Yeah, I think this is where TDD gets more tricky than a lot of TDD practitioners like admit. It's like there's a difference between
Yeah.
like it's not just a passing test and a failing test. It's like,
Mm-hmm.
why does the test fail? Am I going for a
Mm-hmm.
passing test
Yes.
next, or am I going for a slightly different failure next,
Right. The
and so
test-driven
forth?
part is really that you read the error message and you only do things that the failure is telling you to do. That's the trick, right?
Yep.
So yeah. So indeed, it is exactly the same as before, even though we have this exception.
So, okay, so in the interest of like us, myself and chat learning
Mm-hmm.
how
Mm-hmm.
to contribute rather than just like getting step-by-step instructions from you,
Mm-hmm. Mm-hmm.
I'm curious. I'm assuming this invoke gets called by the superclass. Can we look at the source code for that superclass and see
Yeah, I
where
think
it calls
so.
this and why it isn't calling it now?
Well, it's not calling it because this is null, but we can take a look.
Cool.
I don't know what that's saying. Here it is.
So what is this invoke?
So it's saying
47.
find applicable context
Oh, I see.
on
And
this
if it
line.
doesn't find it, it
It returns.
returns.
This
That's
is
what
like
that
a
little
little
thing.
Kotlin thing that says, hey, if it's kind of
Ah,
the syntax is kind of cryptic to me, but I do know it to mean return if it's null. I don't
cool.
understand why it feels weird to me, but yes, that's what it means. So if we get to this
Okay,
point, it's not null.
got it. So, all right, I believe you now.
Yep.
So, so if we change find applicable context to return non-null,
Yes.
um, which what in Haskell we could just return undefined. But I guess here we actually have to build a context value. Okay.
Yep, there's our context.
So now this should blow up, hitting that to do on line 31.
Yes, exactly. It's good to call your shots, isn't it? That's another advanced TDD technique.
And it's good for pool as well.
Yeah, that's right. Well, if you're on the 8-ball, it's very
And
good. Yeah.
and basketball if you're going for well, what is it called? For swag.
Oh, that's right. Exactly. Hey, so look at this. We got our to do.
Swish.
Good news. Okay. So,
So now if we just return, well, okay. If we return nothing, it'll fail in the same way it was.
mm-hmm.
So let's go beyond that and like,
Yes.
can we make any change to the source code in here just to prove to myself
Mm-hmm.
that this is where we want to be making our code change?
Right. So, it's going to be a lot harder from the project and the editor. But if we use this PSI element that we get here as a hook, which is where our cursor is, it's going to be easier. So I propose that we pass this PSI element in the context. We don't have to find the right place. We can just take exactly where it is and replace it to prove that it's doing something there. How does that sound?
Yeah, that sounds great. We're just past. This is just like a step I did last Saturday when we were extracting a like weighted set data structure in Elm and TDDing it. And it was like, oh, we have this data that's provided to an earlier function that gets called. We just want to store that, pass it through for use later.
Mm-hmm. Yeah.
Okay.
Yeah.
Sounds great.
So let's see. So we want to. This is actually going to be. This is like the map call, like the map invocation, and it's for now.
Although for now, it's just going to be any random element where we hit Alt Enter and choose this thing, which could be the whole module, I guess.
Exactly. So
Okay.
this is don't try this at home yet.
Actually, no. At the moment, it's only going to be the word map, right? It's not even going to be the whole list.map.
It's going to be
token,
whatever, right? Like actually. So let's.
Though I guess we'll see.
We will see. Let me just show you to maybe this will help people's mental models a little bit here. Like
cool.
If we look at map, okay, so map. When we're on map, we're on this QID value. So what part of it is that?
Okay, so that contains both.
It's list.map.
Map.
Yeah.
Okay.
So it would replace the word list.map. So it's another good shot that we're calling there, right? So now we can take the context. We've got the map invocation. So what we want to do is, let's see, it's, we want to replace that. Okay. Now,
Okay.
I'm going to have to introduce a new concept here, which is one of the sticking points of working with the IntelliJ SDK. The recommended.
Okay, let me try to do my mental steps
Sounds
first.
good.
So
Do it.
I would probably command click into replace
Mm-hmm.
and see what it takes. So we need a not null
Mm-hmm.
new element.
Yes.
Okay, and if we command click into PSI element, oh, actually, wait, how does
Mm-hmm.
this work? Okay, so in the parentheses, can we type new space, or what is the syntax in Kotlin?
So
We have to know the name of the class.
that's the.
All right, here's where we're
This
getting
is the
stuck.
caveat. This is the
All
part
right,
that
go for it.
requires more than empiricism, but a little help from a mental model. Which
Or a
I've
markdown document.
yeah, that's right. Exactly.
Okay.
And that is that the recommended practice in IntelliJ SDK work is that in order to ensure that you're deriving an AST that's valid, the recommended practice is to reparse from a string into an AST. So you build it up from a string.
Oh, interesting.
And that's done with these PSI factories. So if we go to this class called Elm PSI factory, then we see that. You can see create import or...
This is actually nice because it's a more concise way to create this anyway.
Right, exactly, yeah. Create from text is private. So like, let's see, what would be the easiest thing to do?
Go there and type Elm PSI factory dot and see what it auto-completes for us.
That works? Okay, so Elm PSI factory dot...
We're looking for something that takes a string.
Yes.
Oh, we need an instance
that's
of
right.
the PSI factory?
Exactly, yep.
Okay.
New PSI factory, I think it needs a project, right? Wait, what am I doing wrong here? No.
Should we look at the other intention we were learning from?
Yeah. Oh, it's... Yeah, here's the PSI factory project.
Oh, okay.
Yeah.
Oh, right. There's what? No new keyword in Kotlin? You just call the class as a function.
Which is kind of nice. Yeah. With the project, right? Isn't that what I have here? Why doesn't it like this? Oh, it doesn't.
Then the return type is wrong, yeah.
It's fine with this. Okay, so let's have that PSI factory, and then we can do...
Create elements? No, we want to create one thing.
Value is pretty simple.
Okay.
Hello. How's that?
Yeah, sounds good.
Let's see.
Or a vampire emoji is the other stress tester.
Although that wouldn't be a valid Elm identifier, so that would...
Oh, because it doesn't start with a letter? So H, capital H vampire emoji.
Does Elm allow Unicode in after the first letter in identifiers? I thought it did.
Oh, I think so. Okay, maybe that was removed in Elm 19. That's possible.
Because then you can like put like Unicode.
It's certainly not
space
recommended.
Yeah, you could put like Unicode white space and stuff. Oh, does this need to be lowercase? It's saying it's an invalid QID. Do you know what QID stands for?
No, so I think we're not calling the right function.
Oh, there's uppercase QID and there's create value QID. Oh, and there's also create string constant.
Let's do the string constant. I feel like that'll be
nice.
simpler.
Mm-hmm. Me too. Oh, qualified
Oh,
identifier. Nice.
yeah.
Good.
Okay, that
Good
makes
call.
sense. So it's invalid because we didn't put dots.
Aha.
Text and you put a number. All
Nice.
right, we're really
Oh.
QAing the crap out of this.
Whoops.
I guess I mean the string can contain a number.
Uh.
It's
Yeah.
an opaque identifier. OI.
Yeah.
Oh,
I think I need the actual. There we go. That's this.
oh, really? So we're actually telling it the type of thing that it's expecting to parse, not just like, oh, parse an arbitrary AST node. I guess that makes
Mm-hmm.
sense because the parser is ambiguous if you don't start at the top level.
Yeah. Yeah, and you can see that's
Okay.
actually what it's doing. It's creating something at the top level, f equals this thing. So it's like running the full parser on it. It's pretty interesting.
Yep.
Okay, so this error, this one's always kind of frustrating, but what this means is that it's somehow arrived at an invalid AST. I think the reason for that might be because it's parsing. Well, so you can see what it's created. This AST, that this is the expected and this is the actual. It's elm function call expression and then an elm value and then an elm qualified
Oh,
identifier.
yeah. But look at the left.
It
I
does
think
have
this is
this.
what I was worried about earlier. If you
Mm-hmm.
look like the the regular string part hello, like 5 lines down. So it looks like it put wait, how did it work? It like only replaced the second part of the name. Oh
Oh,
wait, so
after
what's
the
on the right
dot.
side? Mm, wait, so what is happening on the left? The right side is
This is
what
what we
we,
expect on the left.
but why does it have the word hello in there?
Oh, that's weird. Does it say hello in our test? Hmm. Hmm.
But then what you were saying on the right side, it's
That's weird.
wrong. We have a function call with a value expression, which has in it list dot and then a string. Oh
Mm-hmm.
yeah, okay. So that's the same thing. On the right side, line
Mm-hmm.
22,
Mm-hmm.
it's only replacing the word map, not the entire list dot map with our new string.
Mm-hmm. He's saying it removed the parts in blue. Philip is saying, yeah. So
I see.
I think what may happen. So if we navigate up a few levels until so like if we look at this guy, what we
Yep,
want to capture is the function call expression.
got it.
If
Okay.
we find that and replace that, I think it'll result in valid syntax, in which case we'll get a proper diff.
Yep. Okay, I'm with it.
So we can do that just by this element, whoops, is going to be and parent, no, not parents of type. Well, we can just say ancestors dot filter
Okay.
of type. Filter is instance of elm function call expression.
Okay. And that could be nullable, right? So
When
we
we
need to
say dot first, it is making an assertion.
Okay, so it'll blow up. All
Yeah.
right, so we should put a to-do here of
Yeah.
return null if
Mm-hmm.
there is no such ancestor.
Yes.
Okay,
Yep.
cool.
Another thing we can do, I don't know if it'll like, well, we're eventually going to want to change this type to be an elm function call expression, but we can
Yeah, I think we
swing
could
back
do
to
that. I feel like we should have done that before the code change if we're type-driven development
That's true.
first,
That's true.
then test-driven development.
Right. That's fair. Yep.
So what is that? TDD, TDD. Type-driven
TTDD.
development, then test-driven development.
Types test-driven development. Hey, look at this. Cool. Woo.
Okay. Yeah, ship it.
Yeah.
So, okay, so
Well,
all we need to do,
we
like,
could copy paste this and then just have it parse it,
yeah,
and then we'd have
yeah,
a passing test.
let's do that.
We might need to create our own little guy here.
There's got to be one for making an expression, right? Create expression.
Let's see. There weren't as many as I was expecting there to be. I think partially because I think a lot of the work that's been... So this is one of the reasons why I'm excited to contribute to IntelliJ-elm. A lot of the work that's been done is like the unglamorous work of like parsing the AST and inferring types and stuff. But now it's in a place where you can do the fun stuff like transforming ASTs and building refactorings. Not a lot of that has been done yet, but it's in a really good place to do a lot of that. So,
okay, cool. Well, I guess walk us through quickly setting that up then, since we're running low on time.
Yeah, so let's see. So we can, let's see. Let's just do for now create a function call expression. And this is going to return a function call expression.
Okay.
And I'm just going to pass it text for now. We can always refine that.
Looks like line 123, we should say invalid function call instead of whatever.
Yep.
Okay.
Exactly.
Cool.
And then we can say function call expression. Now, for the fun part, I think we can just say this.
Paste it on in. Hopefully they haven't imported list as some other alias.
Yeah, that's true. I have a feeling this might be green. I'm hoping. Then we can commit.
Even though it's no more shippable than it was before.
Yes. Hey.
I mean, okay, I guess it is slightly more shippable.
Slightly more shippable. We could
arguably someone could use this.
You could use it if it matches that exact text. It passed. Cool. So well, let's commit.
And yeah, actually, it's more powerful than it will be later because you can replace any function call with yes. This exact string.
Exactly. That's true.
Wait, I didn't get to revel in the green.
Oh, here it is. Right there.
Oh, where's the green circles? It's just a little check mark?
Okay. I know, that's weird, isn't it?
Okay. Well,
there we go.
Yeah.
Here you go.
So,
3
cool.
check marks.
Yeah, let's commit it. And what do you think? Do we have time to like actually compile this?
I think we do.
And use it in the editor?
I think we do. Yes. So let's foldr. Oops, check out branch foldr. Add initial test setup for foldr refactor. Okay. So, yeah, so the way, now this is pretty cool. You can, I've got this little Gradle. I've like imported the Gradle scripts here. You can say run IDE.
Oh.
Yeah. And it's actually going to build the plugin with our specific version. And then you can play around with it. I think it's going to be unhappy about some things, but that's
just like building an Electron app, except instead of Electron, its entire IntelliJ is the wrapper here.
Exactly. Yeah, it's pretty great. So let's see what happens.
Oh, it's a recursive call now.
Oh yeah.
Yeah, cool. I like to, for this stuff in Elm format tests, just define those as parameters to F2.
Oh, that's smart. Yeah, that's very smart.
But cool.
Okay, so it's not popping up, and I think that's because we haven't registered it. So like if we look at
Okay.
another intention, copy that XML, and this is fold map to fold intention. Now it's going to complain about other things. We can see if it complains when we run our test suite. It might. If we have it here, it might complain that we need some other XML thing somewhere else.
Okay.
Nope. Okay, let's run the IDE. Maybe it'll complain when we do that.
What, other than knowing its name, what other things are you expecting need to get hooked up?
It wants us to make, like if we look for add exposure intention,
Mm-hmm.
there's this folder, and it's going to want us to create this after template, before template description.
Oh, like
describes all the
documentation stuff.
Yeah, it's a little funny, but yeah, I think that's what it's complaining about here.
Okay.
Intention description dir URL is null.
Okay.
Yep. So fine, we'll create it.
Come on, the compiler could have checked that for us.
Yeah,
right?
exactly.
Okay.
What is our?
So we can just copy that for now.
Yes. Ours is called map to fold.
Yes. Map to fold intention. Okay.
And it doesn't care about anything else. It's a little weird. Like I actually never used this like functionality to see the features, but it's kind of interesting.
Where do you even see that stuff? Do you know?
It's like maybe in inspections. I think it's like somewhere in here. Like these inspections show. It's something like that. Yeah, it's kind of odd.
Okay.
Okay, so let's see. Moment of truth. Oh, error. What's the error? Sequence is empty. Okay. Hey, there's our intention. Convert list
All right.
map to fold. Hey, success. Wild
Yes.
success. Wow.
And wait, do you have in this one the extract to let? Can we move over to the lambda after that and extract the
extract the lambda?
the function? Yeah. To a variable. Oh yeah, select the whole lambda and then it's there we go. Step. Let's call it step, I guess.
Cool.
I like to call it.
I wish there was like lift to top level, but yeah, that's pretty cool, huh?
Yep.
So
yeah. And then is there one yet that'll like convert those lambda arguments to be parameters to step?
No, but that's on my list for sure. Yeah.
Yep, first baby step on a long journey.
That's right. Exactly. Oh man, it takes a lot of love. But I mean, this one, like, so I'll give like a little sneak peek of like how I would approach iterating on this. So first let's
cool.
First let's commit this because we made some things happy. Sorry about my jar noise stuff there.
I have jars all over my house, in the pantry, in the kitchen, on the desk.
I gotta put them in the dishwasher.
What do I have here? I've got some jar candles.
Ooh.
I've got a jar of peanut butter. All kinds of jars.
I much prefer those jars. Okay, so what I have been really enjoying in this workflow, because it makes me think how nice it actually could be to have a step debugger in Elm. Contrary to popular belief, I've heard other people voice this opinion that it could actually be useful in Elm, as useful as the time traveling debugger is. Sometimes it's handy to just step through function calls and inspect values.
Yep.
So this is what I like to do. well, first let me extract this guy. This is going to be like our function call. Text. And like what I want to do, like here, let's set ourselves a little exercise.
So, okay, yeah, and like structurally, basically that first token is
did you see that? That just worked.
constant. Ooh, nice.
Wow.
Oh, with the string interpolation?
That's
Lovely.
sweet. So this is
So
our little
then,
target. You see where I'm going with this?
yeah, and then like the last two arguments, the empty list and the items, those are just literal nodes that are coming out of the original.
Yes.
And then the reference to F is also literal coming out of the original. And then
Exactly.
just the names, item, and results are generated.
hard-coded.
And actually, in there's the way to like set it up so that there's little placeholders, or like your cursor will go to have the word item selected so you can rename it to what you want right after you finish.
Yeah. Exactly. Oops. Yes, exactly. Yeah, so this is going to be like our goals here is we want this thing is like the I don't know, inner function name. Fortunately we've got rename refactoring, so if we think of something better we can change it.
So what does this will mean that we actually have to convert some of the original code into text,
yes,
so that we can insert it here and then parse the text back into AST.
Exactly, which we can do very easily. So now this is pretty cool because we've Luke is saying the F# debugger is good. I want to take a look at that. Neat. So this is actually a really fun part. We've done all of the hard work of like wiring things in, all the grunt work, made the IntelliJ SDK happy. Now we get to do the fun stuff. So I'm going to run our test that we were running with the debugger. And what it's going to do is it's going to stop right here. We're going to have the Elm function call expression, and then we can inspect it, and we can see if we can generalize one of these instead of hard coding it.
Got it. And we have everything else in scope, so we can like dig down into stuff in the context and so forth.
Mm-hmm.
Excuse me.
Yes. Yeah. It's like a little playground now, so we can say.
Well, I think it's actually a big playground because we have project and editor in scope, which probably has references to like IntelliJ itself and all that.
Absolutely.
We can access the class loader through here. We could do anything.
That's true. Let me bump up the font size here.
Okay. Yeah, this is one thing that VS Code actually does well. When you bump the font up, it bumps up everything, every panel, every plugin thing.
I know, exactly. That stuff needs refinement. But, well, okay, so here's the text. List.map f items. So what do we have available? So this is why having like a debugger is so cool. So target. So let's look at target.text. List.map. Well, actually, list.folder is hard-coded.
Yep. So we want to grab F, essentially.
Right. Okay,
so we want like the arguments, argument sub 0.
Mm-hmm. Which we can do. Sometimes it reads better if you do this.
Okay.
Because it doesn't eagerly evaluate a sequence. So there's F.
Okay.
There's F and there's items. So.
So is there list destructuring in Kotlin?
I think there is. I think we can do like.
So there's an interesting thing here where if there's more than 2 arguments passed
it drops
to list.map, we want to actually retain those.
Yeah.
Which means then we'd have to insert. Well, no, we wouldn't have to insert parens here.
How would you pass more than 2 arguments?
I mean, if you say list.map, blah, 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 something, it would never be valid because list.map always returns a list.
So
but
I would say that
syntactically it's valid.
We can verify that in find applicable context. And in fact, in find applicable context, we can say if it find a function call expression, assert that it has 2 arguments, and then we can destructure those two arguments, pass it along in the context, or not pass it if it doesn't meet those criteria.
Yeah, I mean, that's an interesting usability question, though, because,
Yeah.
and actually, I've thought about this a lot in Elm format.
Mm-hmm.
I want to avoid making the tool too smart because then I end up accidentally restricting what the user can do. It's like, okay, maybe they have a typo. There's a comment at the end, but they forgot the dash dash, and it's like they're passing extra stuff accidentally. But still, if it's possible to make the tool automatically do the right thing, I've been thinking like it's better to make the tool more lenient. Or there's some mantra about this where you about like being lenient on what you accept but strict in what you output.
Oh yeah, which is like the HTML thing, like be tolerant of bad input and strict about your output.
Oh, okay. Well, in HTML, that's maybe not an example I want to highlight.
Well, that's the thing.
It's like a general engineering practice in general,
right?
Of working with, like, interacting with users.
Right. Yes.
Oh yeah. Okay. Philip's suggesting another to-do we need where list.map only has one argument passed. Yep.
Exactly.
Which actually should work here just fine, and actually that's a better reason to make it more generic, because then the single argument case will just work for free.
Wait, the single argument case. What would we do? Can we write it out?
Because really, we're taking So if we look at this real quick, list.map, the input. So describing the transformation as simply as possible, we are taking the list.map, changing it to list.folder, taking the f, and changing it into the synonymous function that uses f.
Yep.
Then we're adding a parameter of empty list.
Yep.
And then everything after that we want to leave alone.
Yeah. Oh yeah. Good call. Good call. Right. Okay. So, hey, it passed. So I really love this process of like hard code and then like extract things so that you're just, as we did, using automated refactorings so that you haven't changed anything. You've just sort of unlocked it so you can de-hard code it. And then use the step debugger and now it's just a little game where it's like, get that value.
Yeah.
I really like that process. So, I mean, I think that's
nice.
A fair commit. We've made it a little more robust.
Cool. And yeah, how are you on time? I wanted to circle back on talking about inlining, but if we don't have time, I can do that on one of my future streams.
I think we can chat for why don't we go for like another 15 minutes and just do a little wrap up discussion maybe.
Cool. And yeah, I'm definitely interested to play around with this, so I expect I'll probably be giving one or two of these a try in the future. And actually, I don't know if you're interested in sharing that list of potential refactoring ideas.
Yes.
So we can come to that in a second. But yeah, to that question earlier, what was that? Was that Philip that was asking earlier about inlining? So yeah, like Dylan mentioned earlier, I've been working kind of behind the scenes on a refactoring command line tool that's kind of based on Elm format and is also based on, if folks remember when Elm 19 came out, Elm format kind of had this secret feature for upgrading code from Elm 18 to Elm 19, where it would automatically convert to new function names. It would do the fancy thing with, if you used HTML style in the old format, it would convert it to the new format, which kind of involves some tricky manipulations and handling lists differently. So anyway, that tool is kind of based on an interesting approach that's more focused around inlining rather than pattern matching in a sense. So maybe, let's see, if we go back to that Notion doc with our code example, maybe I can kind of walk through the steps of how that tool, like the principles behind that tool.
And I think this is public, right? So we can share this guy.
I guess we'll find out.
I think it's good. Here we go. Here's the link. So so Aaron and I actually part of the impetus of this document was that like Aaron's got some sort of refactoring functionality he's working on, and I'm really amped up about like doing some intellij-elm contributions, and we're like, well, maybe we'll end up like rewriting some of the same features, but at least we can like share our sort of context around what's a good set of recipes of functional refactorings in Elm, and like what are the edge cases and some examples and stuff like that. So that's what this Notion book is.
Yeah. And like the hard part isn't really implementing these. The hard part is kind of getting the base framework and the patterns for implementing these quickly.
Yeah.
And once that's set up, I mean, we can learn from the usability experiences from each other and all that.
Exactly. Yeah.
But yeah, let's jump back to that code example that we started with the before and after.
Cool.
And maybe copy that down to a new section. So if we're starting with list.map f items, I guess let's keep the whole thing as a good illustration. So the tool I've been working on, the next step would basically be inlining a special definition for list.map. So let's put in a new line here.
Oh, like a recursive function call?
Yeah, potentially.
Because recursive function calls are interesting because you can terminate early, which list.map and list.fold don't do.
I see.
But maybe that's not. Yeah.
Yeah, I think that might be a little different.
Okay.
So the next line, the next step in the transformation would be the same, but the list.map will be replaced with parentheses, and then a lambda taking, I guess it would be f prime or f underscore or something. Sure, f1. And then the body of that lambda will be the code below, the list.fold r, and then that inner lambda up, including the empty list at the end. With the f there being f1. So that's basically just a mechanical inlining of list.maps to this particular alternate definition of list.map in terms of list_fold r. But then the big thing I've been working on my tool is doing some simple replacements, but then doing a pretty complicated but accurate and also like heuristically pleasant simplification of the code after this step. So then it would basically do this, and then it's going to start looking for ways to simplify the replacement that it just stuck in. So in this case, we have an anonymous function that's immediately then passed an argument. So it would take that f argument and inline that, basically apply f to the lambda. So then the lambda goes away and f1 is replaced with f everywhere it's used.
Right.
And then
cool.
Oh, well then we're done. Then we got to where we wanted.
Oh, cool.
So that's a pretty simple example actually, but it highlights that interesting relationship between, on the one hand, like complicated pattern matching based transformations like we were doing in Elm IntelliJ, and kind of what excited me about this approach and why I really started to run with it and invest a lot of time into it is that this alternate approach of like inline something and then simplify, I think has a huge amount of potential for making it easy to handle all kinds of edge cases. Like we were just earlier discussing the edge case where like, oh, what if there's extra arguments passed to this? Or what if there aren't any arguments? So actually, we could run through this example. Let's start another example here where all we have is list.map as our starting point, and f items isn't applied, and f also isn't applied.
Okay.
So this is a case where in Elm IntelliJ, if we implemented this refactoring, we would have to do some extra special matching and special case handling of
Gotcha.
this case, which is kind of weird, but also, I mean, there's no reason you couldn't transform this into the same thing.
Yep.
So if like in my tool, it's basically implemented
Basically
for
this part,
free
right? Yeah.
based on that inline definition of just, oh, it turns it into that. And then later,
Right.
if you do apply arguments or whatever, it could then later be simplified. So that's been the
That's
interesting
interesting.
realization that I've had working on my tool. And
It's
I
like
like there's a
composable
yeah,
micro refactorings, like,
yeah,
and often when people say micro refactorings, they think like rename refactoring and things like that. But this is like even more micro, that you could create those
yeah,
refactorings from like 5 of these steps.
yeah, yeah.
That's
And
cool.
I feel like the potential, it's just super powerful in
Hmm.
terms of like reducing the amount of effort that's required to add
Hmm.
new, I guess, intentions in the language we've been using,
Yeah.
where all you
Yeah.
have to do is essentially define, oh, this old thing, this like tiny piece, no pattern matching involved, becomes this, and then the simplification is kind of like a generalization of handcrafted pattern matching transformation logic in a lot of cases. So
Yes.
anyway, like
That's fascinating.
that's the
Huh.
idea that I want to be sharing more in the
That's
next couple of months, and I'm like
That's
really
really
excited
interesting.
about it.
It reminds me of this idea of um, like composability and functional programming, that like you can make really robust and easy to grok building blocks. Much like the Unix toolchain philosophy, that like you don't like you make grep and you make you know tail and whatever little utilities that you can piece together. You don't make a utility to do like every specific thing, and then
Yep.
those can be more robust and easier to understand. And that's a really
Yeah.
that's a really interesting idea applied to the notion of refactoring tools.
And I think it also kind of touches on this concept of the shift from like imperative and
Mm-hmm.
or programming to functional programming, which is more like declarative in nature,
Mm.
where it's almost like
Mm-hmm.
we're defining here a language to define mathematical transformations of code, but then
Yes.
we have a super generic engine that can take those
Huh.
definitions and learn how to apply them in like
Right.
a wide like the like completely extents or what am I trying to say? Like it can apply
Mm-hmm.
them
Yeah.
in all the possible cases that this would be relevant, even if it
Mm-hmm.
looks very different in outcome, depending on the context it's applied in.
I'm wondering if because like for mathematicians, there's this like people who are really good at math. Often you see them just like going through these like factorings, it's called in math, where they apply
Hmm.
all of these theorems and laws, and they know by this theorem that if you have something in this form, you can change it to this form, and then taking that form, you can apply it to this other form. I wonder if there are mathematical
Yeah.
tools that academics use that maybe we could learn from, because sometimes cross
Yeah.
pollination can be really helpful to like leapfrog and get past our pre-existing ideas about how to approach something.
Yeah. And I think like that gets to kind of the intersection of like in mathematics,
Mm-hmm.
proof assistance tools
Yeah,
and programming languages, which is like where
exactly.
Idris as a language is starting to explore a bit, which,
Exactly.
yeah, that's like
That's how I
super
think of
exciting.
Elm too. That's totally how I think of
Yeah.
Elm. Like, given this thing, I know I can give you this other type of thing, and you're just assert like a type is a proof. A type is a proof that you say, um, I can never arrive here except through these paths, and it helps you. Like the way I think of
Mm.
typed functional programming is that you're checking your work in a way that the compiler can keep track of the things that you've proven, and then it can give you those things that
Ah,
you've proven as guarantees. So like if you prove
like,
something is a valid email address by calling some function that will only return that type conditionally, it returns like a maybe or result email address or something, then or the only way you can get like an auth token is from this HTTP request. That's like a proof that that action has happened. Now you have to be sure that
Yeah.
that part of the code can only occur in those valid situations where you have an auth token. But once you know that, then the compiler keeps track of the fact that you've proven that you've gotten that somehow.
Yeah. Huh. Yeah. That idea of types as proofs is something that's been a bit elusive as a concept, but I really like that explanation of like tying it down to say like, okay, here's the facts that we know, and then the compiler now is able to use those facts to help us, like remind us if we ever violate those facts in a sense.
Exactly. I think about it that way in my internal monologue a lot when I'm coding, like, okay, given, like, if I had this, I know I could give you this. Like, I could prove that I can do this. And more and more I'm thinking about, especially with Elm. Elm really lends itself so much to proving that two things are equivalent. And just, like if you return a record, if you return a full record with 100 fields versus returning a string that then is updating this one field in that record, that's a proof that like that function doesn't touch any of those things. Now you could prove that by manually inspecting the code, but that's like an imperative proof. But the type is like a declarative proof that says like the only thing this function does is it returns a string. It changes the address one field to use some standardized format where whatever, it's all uppercase and it turns RD period into road and whatever. That's the thing. Well, does it touch anything else in the address? Does it touch the first name, last name, city? If it takes a giant record and returns a giant record, then you have to imperatively go through and prove that to yourself. If it returns a string and then it calls that in that one place, that proves that. Or if it's an extensible record where it takes something that has address one field and it returns a record that has an address one field, that's also a proof that it doesn't depend on any of those other things or touch any of those other things. Anyway, but it's like, oh man, it's so nice.
To master that, you got to hire Dylan as a consultant to help your team really understand the subtleties of that, right?
Hopefully the refactoring tools will make that obsolete. Then we just need to monetize that so I can play with refactoring tools all day.
Cool. Well, should we wrap up here?
Let's wrap it up. Any parting links or thoughts you want to leave people with, Aaron?
I'm recently out of my job at Neurid Inc. There were big layoffs there, so I've been streaming a lot more.
Yes.
Ton of Elm stuff in the last couple of weeks. I think I've done 40 hours of streaming this month now.
That's amazing.
So you can check me out on Twitch, and also I'll post my Twitter. I've been trying to announce in advance what my streaming schedule is. I get that's my tentative schedule. Well, actually, wait, that's not right. Go to the About page. I think my more accurate one is on here.
There we go.
Yeah, okay. I guess I'll be committing to my tentative schedule right here. So Wednesday, I'm going to be doing some more Elm Animator stuff. We've been working on making this generalized approach for doing arbitrary page animations, where say you have like an image on a previous page and now that same image is somewhere else on the new page, but even in a totally different place in the DOM structure, being able to have an easy way to like make it animate during the page transition is what we've been working on. Then Friday, I've been learning about the new Elm Spa release and applying that to the bigger app that I'll be working again on Saturday, which is a mobile-first recipe management and experimenting in the kitchen web app using test-driven development. Not quite as strict as we were today, as I forced Dylan to be today. Check me out, and I'm glad to see. It's been a while for you, Dylan, on your stream. You've had a bit of a break,
Yes, yeah.
you've been focused a lot more on guests in the past, and I'm looking forward to seeing more of that in the future too.
Awesome. Yeah, no, I'd love to join the stream, talk about refactoring or Elm pages or TDD. So many things we could discuss. Yeah, well, great. It was a real pleasure having you on, Aaron, and thanks. We'll see you online on your stream next time.
Yeah, super fun. Bye, everybody.
Thanks
Thanks,
everyone
Dylan.
for joining. Thanks, Aaron.